Bismillahirrahmanirrahim. Welcome to Applied Thermodynamics by McConkey with Dr. Abid Hussain. In this lecture, we are solving problem 4.11. So, problem is 1 kilogram of a fluid at 2.62 bar and minus 3 degrees centigrade is compressed according to a law PV is equal to constant to a pressure of 8.2 bar. Calculate the work input and the heat supplied when the fluid is air and when the fluid is a refrigerant initially dry saturated with the property given in table 4.2. This is table 4.2. Sketch each process on a TS diagram. So first we write given data. So mass is 1 kg. Initially fluid pressure is 2.62 bar and temperature is equal to minus 3 degrees centigrade, which is in Kelvin equal to minus 3 plus 273 Kelvin, which is equal to 270 Kelvin. To a pressure of process according to a law PV is equal to constant. Process is according to law PV is equal to constant. And after compression, pressure increases, so final pressure is 8.2 bar. Calculate the work input required are W and Q. Number 1 and for 2 find Q and sketch the process on a TS diagram. Sketch the process on a TS diagram. So first we solve part number first. So first we sketch TS diagram. Initially in part 1 the working fluid is air, so initial pressure is P1 which is equal to 2.62 bar 2.62 bar, and after compression pressure increases to P2 is equal to 8.2 bar. So this is point 1 and this is point 2. At temperature T is equal to minus 3 degrees centigrade. Temperature is in degree centigrade and entropy is in kilojoule per kilogram per kg. This is TS diagram for part number 1. Now in part number 1 there is one assumption that air is perfect gas. So we will use perfect gas equations. So according to perfect gas equation, Q is equal to RT natural log of P1 divided by P2. So Q is equal to, for air R is equal to 0.287 kilojoule per kilogram per Kelvin, and temperature is minus 3 degrees centigrade, or in Kelvin is equal to 270 Kelvin. Natural log of P1 divided by P2. P1 is 2.62 bar and P2 is 8.2 bar. This bar will be cancelled with this bar. So Q is equal to, multiply 0.287 by 270. So 0.287 multiplied by 270 is equal to 77.49 kilojoule per kilogram. This Kelvin is cancelled with this Kelvin. Multiply by natural log of 2.62 divided by 8.2 is equal to minus 1.141. So Q is equal to, multiply these two values, the answer will be minus 88.416 kilojoule per kilogram. Negative sign means that heat is rejected. heat is rejected. Now we find W. So Q plus W is equal to U2 minus U1. But as we know that for perfect gas U1 is equal to CVT1 and U2 is equal to CVT2. And U2 minus U1 is equal to CVT2 minus CVT1. CV is common, so which is equal to CV T2 minus T1. T1 and T2 are equal, so CV T2 minus T1 is equal to 0. So U2 minus U1 is equal to 0. So Q plus W is equal to 0. U2 minus U1 is 0 for a perfect gas, not for a steam. So now the value of Q is minus 88.416 kilojoule per kg plus W is equal to 0. So W is equal to minus 88, on other side will be plus 88. Plus 88.416 kilojoule per kilogram. And positive sign means this is work input. Work input or work of compression. Work of compression or work done on the system. Now we are solving part number 2. So first we draw TS diagram. Temperature and degree centigrade and entropy and kilojoule per kilogram. This is saturation curve. And part 2, this is mentioned that initially steam is dry saturated. Initially refrigerant or steam is dry saturated. Working fluid refrigerant is a dry saturated. Dry saturated means that it is on saturation vapor. This line is called saturation vapor line. So P1, this is constant pressure line P1, and this is equal to 2.62 bar, and this is constant pressure line at P2. P2 is equal to 8.2 bar. Initial point is here. Initially the steam is dry, so it means that initially point 1 is unsaturated vapor line. Now we find whether point 2 is in wet region or in superheated region. So for point 2, first we find V2. So as process is according to PV is equal to C. So P1 V1 is equal to P2 V2. So V2 is equal to P1 V1 divided by P2. P1 is equal to 2.62 bar multiplied by V1. V1 is equal to Vg from table. V1 is equal to Vg. Initially steam is dry saturated, which is equal to V1 is equal to Vg, and Vg is equal to from table 2. Vg is equal to 0.0757 0.0757 meter cube per kg. So 0.0757 meter cube per kg. Divided by P2. P2 is equal to 8.2 bar. Now bar will be cancelled with multiply these two value and divide by 8.2. So V2 is equal to 0.0241 0.024187 meter cube per kg. Now V2 and and from table 2 at pressure is equal to 8.2, Vg is equal to 0.0248 meter cube per kg, but 0.0241 is less than 0.248 as V2 is less than Vg. It means at this point this is Vg, this is Vg, but V2 is less than, it means that V2 is in wet region. So refrigerant 8.2 is in wet region, is in wet region. It means that point 2 will be here. This is point 2. So this is point 2 and this is TS diagram for part number 2. This is point 1 and this is point 2. Point 1 is unsaturated vapor line and point 2 is in wet region. Now first we find W, work done. We know that work done is equal to P1 V1 natural log of P2 divided by P1. So P1 is equal to 2.62 bar. 1 bar is equal to 10 power 5 Newton per meter square. V1 is equal to 0.0757 Newton meter cube per kg and natural log of P2 is equal to 8.20 bar and P1 is equal to 2.62 bar. This bar will be cancelled with bar, meter square will be cancelled with meter square and 1 meter will be left here. So W is equal to 2.62 multiplied by 10 power 5 multiplied by 0.075 is equal to 19833.4 Newton meter per kg multiply by natural log of 8.2 divided by 2.62 is equal to 1.1409. So W is equal to, this is equal to, multiply these two values, the answer will be 22629.10. Newton meter is equal to joule per kg, but we will to convert joule into kilojoule, so divide by 10 power 3. So answer will be W is equal to 22.629 kilojoule per kg. And if we round this, so this will be equal to 22.63 kilojoule per kg. And the positive sign mean that this is work input. So a positive sign means that this is work input. So work input or work of compression or work done on the system. Now we find Q, so S Q plus W is equal to U2 minus U1. So first we find U1 and U2. First we find U1 and U2. U1 is equal to H1 minus P1 V1. H1 is equal to Hg. H1 is equal to Hg from table 4.2. Table 4.2. H1 is equal to Hg, which is equal to 292.94. 292.94 kilojoule per kg. So U1 is equal to 292.94 kilojoule per kg minus P1 is 2.62 bar. 1 bar is equal to 10 power 5 Newton per second per meter square. V1 is equal to 0.0757 meter cube per kg. So U1 is equal to 292.94 kilojoule per kg minus multiply 2.62 by 10 power 5 and 0.0757. So this will be equal to 19833 and now meter square will be cancelled with meter square. This is Newton meter is equal to joule per kg, but this is in joule per kg and this unit is in kilojoule per kg. So to convert this into kilojoule per kg, multiply by kilo, and kilo is equal to 10 power 3, so divide by 10 power 3. So u1 is equal to 292.94 kilojoule per kg minus 19.8 divided by 10 power 3, which is equal to 19.833 kilojoule per kg. So u1 is equal to 292.94 minus 19.833 is equal to 273.107 kilojoule per kg. Now we are finding u2. So u2 is equal to h2 minus p2 v2. First we find h2 as h2 is equal to hf. This is form 2 is in wet region plus x hg minus hf. So from table 4.2 hf is equal to, at pressure is equal to 8.20, at pressure is equal to 8.2 bar, p2 is equal to hf is equal to 144.29 kilojoule per kg and hg is equal to 313.05 kilojoule per kg. Now h2 is equal to, hf is equal to 144.29 kilojoule per kg plus x. First we found x. First we find x2. We find x2. So as v2 is equal to x vg2 from table 4.2, at pressure p2 is equal to 8.2, vg is equal to 0.0248 meter cube per kg. So we can easily find x2. This is x2. x2 is equal to v2 divided by vg or vg2. v2 is equal to 0. v2 already we found v2. We have found v2. So v2 is equal to 0.024187. 0.024187 meter cube per kg and vg is equal to 0.0248 meter cube per kg. So x2 is equal to 0.024187 divided by 0.0248 is equal to 0.975. This is dryness fraction. Now h2 is equal to hf plus x2 hg minus hf. So h2 is equal to, hf is equal to 144.29 kilojoule per kg plus x2 is 0.975, hg is equal to 313.05 minus 144.29, unit is kilojoule per kg and unit is kilojoule per kg. Now simplify this. h2 is equal to 144.29 kilojoule per kg plus 313.05 minus 144.29 and multiply by 0.975. So this is equal to 164.54 kilojoule per kg. So H2 is equal to, add these two values, the answer will be 308.83 kilojoule per kg. Now we are finding U2. So U2 is equal to H2 minus P2 V2. So H2 is equal to 308.83 kilojoule per kg minus P2. P2 is 8.2 bar, and 1 bar is equal to 10 power 5 Newton per square meter, and V2 is equal to 0.024187 meter cube per kg. But this value is in kilojoule per kg, and this value, second value, is in joule per kg. So to convert this in kilojoule per kg, divide this by 10 power 3 and write in denominator kilo. Kilo and 10 power 3 are equal, so multiply and divide by 10 power 3. So this value will be converted into uh, kilojoule per kg. So this is equal to 308.83 kilojoule per kg minus meter square will be cancelled with meter square. This will be meter. Newton meter is equal to joule, and this is kilo. Kilojoule per kg. Unit will be kilojoule per kg. And if we multiply 8.2 by 10 power 5 by 0.04187 and divide by 10 power 3, the answer will be 19.833. So U2 is equal to 289 kilojoule per kg. Now we can find Q. So as we know that Q plus W is equal to U2 minus U1. So Q, the value of W is 22.63 kilojoule per kg, is equal to U2 is equal to 289 kilojoule per kg minus U1 is equal to 273.107 kilojoule per kg. So Q is equal to 289 minus 273 is equal to 15.893 minus 22.63, shift to other side, then it will be minus kilojoule minus 22.63 kilojoule per kg. So Q is equal to minus 6.7 kilojoule per kg, and the answer is negative. Negative sign means that heat is rejected. And so problem 4.11 is completed. And for more videos, please like and subscribe my YouTube channel and share with your friends. Thank you.